Hi, this is Brittany Newkirk, and this is my geometry teaching task. Previously, we have learned how to find the area of rectangles, triangles, parallelograms, trapezoids, and circles. Now we are going to expand this knowledge and learn how to find the area of an acute triangle and a parallelogram, relating them both back to the area of a rectangle. The formula for finding the area of a rectangle is the length times the width because you're calculating the square units of the entire rectangle. Therefore, multiplying the total squares in the length of the rectangle by the total squares in the width of the rectangle will give you the total squares in the entire rectangle. Now we are going to talk about the formula for finding the area of a triangle and a parallelogram. The area of a triangle equals 1/2 the base times the height. If you get rid of the 1/2 entirely, you're going to be left with base times height. And as you can see, this is very similar to the area of a rectangle, which is simply length times width. Here you can see the area of a parallelogram is equal to base times height. When we find the area of a triangle, we want to find how many square inches the space inside can hold. In order to do this, we can take another triangle that is the same size and the same shape and put it on the opposite side of the triangle to form a rectangle. And you can see this here with this right triangle. It formed a rectangle when we copied it and moved it up here. It takes two triangles to form a rectangle. You can then visually see that 1/2 of the area of the rectangle is going to be equal to the area of the triangle. You can do this with all types of triangles. So if we have an acute triangle like we do right here, we will copy and rotate the triangle just as we did with this right triangle. And we can then see that this shape forms a parallelogram. An acute triangle means it has an angle that is going to be less than 90 degrees. So here's an acute triangle compared to a right-angled triangle and an obtuse triangle. The area of a parallelogram is base times height, and the area of a triangle is half the area of a parallelogram. The area of any type of triangle will always be 1/2 base times height. When you're finding the area of a parallelogram that does not have a right angle, you solve this using base times height. If you cut off a piece of the parallelogram and move it to the other side, as shown here, you can see it forms the same shape as the rectangle. Now you can see the area of a rectangle is the same area as a parallelogram. Now we are going to go through a couple examples. So the base is always considered the bottom. So while we're finding the area of this acute triangle, we see that the base is 12 inches. Then we need to find the height. The height needs to be thought of as the drop-down point. Heights are always straight up and down. They're not slanted like these two sides of the triangle. So we can see here that the height is going to be equal to 6 inches. So then we're going to multiply 12 by 6 and divide that by 2 because the area of a triangle is equal to 1/2 base times height. So 12 times 6 divided by 2 is equal to 36 inches squared. And then down here is the same example as shown up here. If you take the same triangle and flip it over and move it to the top, it then forms this parallelogram shape. So next we are going to do an example for the area of a parallelogram and talk about how it is related to the area of a rectangle. So our area of this rectangle is going to be our base times height, which is 5 times 4. When we look down at our parallelogram, the base is still going to be 5 and the height is still going to be 4. Again, the height is the measure from top to bottom, going perpendicularly straight down. So here's the height. We are now going to do a little bit of visualization. We are going to take a chunk of the area from the parallelogram right here and move it over here to the right side. So this triangle on the left side that helps make up the parallelogram is going to be moved to the right side. So we will not be taking any area away, we are just moving it over here. Now our parallelogram looks identical to this rectangle up here. So by taking some of the area on the left and simply moving it to the right, we have just reconstructed this rectangle. So they have the exact same area. 5 times 4 is equal to 20 units. 5 times 4 is equal to 20 units squared. So the area of this parallelogram is also going to be base times height. And as you can see, they are the same shape. Thank you for watching.